Hello and welcome to the Rowan University NASA E-3 test trailer demonstration. I'm George Lecakes and I will be presenting this virtual reality demo. First thing you'll notice is the actual model used here, and this is a model of the MTTP trailer, or the Methane Thruster Testbed Platform, down in Mississippi at Stennis Space Center. This was constructed using reference images provided by Stennis of the actual trailer from multiple different views. Because of variability in the plans with the current setup, it was decided to only use reference images to model this. It was modeled using Autodesk Maya. The next part that you'll notice past the model is the different visualization setups provided inside of this demonstration. The different visualizations you see here are for temperature, pressure, strain, and current, as well as state. Now, typically, the data is given to us in a large Excel spreadsheet, and this Excel spreadsheet contains thousands and thousands of data points over time. And this is very difficult to go through and actually understand what is going on for any particular kind of data, such as temperature or pressure. So what we do is we take all this information and we put it inside of a virtual demonstration and play it for you without the numbers. So we can turn these numbers off and you can just look at the actual visualization and kind of get an intuitive idea of what is going on and see patterns in the actual process. So as we can see, we have a temperature thermometer, a pressure sphere which shows the relative highest pressure, with a small blue sphere internally which will show the current pressure. So as the sphere gets larger, you know the pressure is increasing. We also have a lightning bolt above it which will flash when the igniter is being ignited, as in right now. Temperature is rising. We can look at the temperature in a different way. So we can look at it as in terms of a snowflake, a water droplet, and a flame, to also give us an idea of what's going on. Also, we have strain, which currently is sort of wildly dancing up and down, and this is because the strain gauge is reacting to wind, which is blowing the trailer in this test firing. Now we also have states, and states tell you what the actual state of the valve is. There are several valves in this setup, and for this particular one, you notice that there's a COM or command state as well as an actual valve state. When the colors are the same, that is when it's red and red or green and green, the two things are in agreement. That is, the command for the valve agrees with what the current state is. Now, for red denotes closed and green denotes open, and a yellow state means that it is currently in between those two. Now, whenever you have different colors, it means they're not in agreement. Now, when it's red and yellow, that just means you need to wait a little longer because it takes time for the servos in the valve to actually open or close. However, whenever you have red on green or green on red, you know that there's an actual problem with it being commanded to open or close and the valve actually not performing its duty. So if we come over here, we can take a look at some other sensors. Here you'll see several other sensors around here, and some of the sensors are actually equipped with feedback, which allows you to see how much feedback is in the actual transmission of the sensor data. And here's a problem. It's being commanded to be open. However, the state says it's closed. Now, we are also experiencing quite a bit of feedback, however. So this might not be a situation where the actual state isn't closed. It might really be open, but it could be the sensor telling us it's closed. And so by looking at the feedback, we get a sense of the health of the system, and we're able to say that's probably a bad sensor. Since the thing is actually firing, heat's building up and everything, most likely we need to change that sensor out. It's probably not a faulty valve. And in this case, that is exactly what needed to happen. Also, you'll notice several GUI elements in this visualization. The first is a mini map on the top, and a red sphere denoting where you are in the actual scene. And as you see, as we move around, the dot follows us. Now, for such a small demonstration, it's not really needed. However, in the future, we plan on implementing something similar to this with very large, several hundred feet tall and wide installations for testing the large rockets that are probably going to take us to the moon and Mars, maybe. So for such a large installation, a map will help us understand where we are in reference to all the other parts. We can remove this too from the scene if we don't like it by just clicking M. The next part is the
visualization GUI, which allows us to pick which visualization we want to see. So if we want to see gauges instead of pressure spheres, we can see gauges. If we want to see strain bars, we can look at them. Or if we want to look at, the temperature bar instead of just a relative hot, cold type situation, we have that as well. We can also get rid of this. Next up is what you saw me use in the very beginning, are the visualization viewport buttons, which allow us to quickly move around to different views. And for some of these views actually help us. The top-down view gives us a good idea. It's very easy for us to see what the different states are. However, a front view just allows us to get to the front quickly and maybe move around easier. And these can also be, this little GUI can also be turned off just with the V key. Now the final bit that I'll mention is the shutdown state. Right now it's in a normal shutdown, which means the simulation is shutting down normally. It's expected to shut down this way. Now, the one that you really have to look out for is the ES, or emergency shutdown. And if that turns red, you know you have a problem on your hand and that the system had to shut down under emergency conditions. That pretty much wraps up this visualization demonstration for the MTTP trailer down at Stennis Space Center. I am George Lecakes. Thank you for watching.